All right, let's do problem number 59. The expression F equals ARV plus BR squared V squared gives the magnitude of the resistive force in newtons exerted on a sphere of radius r in meters by a stream of air moving at speed v in meters per second, where a and b are constants with appropriate SI units. Their numerical values are a equals 3.1 times 10 to the negative 4 and b equals 0.870. Using this expression, find the terminal speed for water droplets falling under their own weight in air, taking the following values for the drop radii: A 10 micrometers, B 100 micrometers, and C 1 millimeter. For A and C, you can obtain accurate answers without solving a quadratic equation by considering which of the two contributions to the air resistance is dominant and ignoring the lesser contribution. Okay, let's start this problem by drawing a free body diagram of this water droplet as it falls in midair. So that is the water droplet, and going straight down, you have mg, and going up, you have the resistive force, which equals to F equals ARV plus BR squared V squared. And so you will start this problem by simply summing your forces. So you have the sum of your forces. Oh, and up is positive. Sum of your forces is F minus mg. And since the question does ask us to find the terminal speed for the water droplets, ma will be 0 since it is not accelerating at terminal velocity. And so we are solving for v in this f expression here. So I'm going to isolate f. And before we continue, in this expression here, we know every single term. A is given to us, R is given by the problem, we just don't know V. And we also don't know M. And so in order to find M, we are going to use the density of water. D equals, density equals mass over volume. So if you isolate mass, you have density times volume. So the density of water is 1,000 kilograms per cubic meter. And the formula for the volume of a sphere is 4/3 pi r cubed. And so your mass expression will be 4,000 pi over 3 r cubed. And so we can plug that for mass later. And so now coming back to here, I'm going to plug in, this f expression here. I'm gonna write it out. Equals, and then mg. And now looking at this, we still have, this is actually gonna be, a quadratic, because v squared and v, v is now your only unknown here, but we have v squared plus v, so we can tell this is starting to look like a quadratic. So I will move mg back over to the left side. And since this will turn out to be a quadratic, I will write it in a quadratic friendly form, having BR squared V squared at the front plus ARV minus mg. And now all I'm going to do is plug in all the numbers given to me in the problem. So B is 0.870. R for part A is 10 micrometers, or 10 times 10 to the negative 6 meters, and then squared V squared. So that's our unknown. It's like x squared. It's just like solving a quadratic now. And now plus A is 3.10 times 10 to the negative 4. It's given by the problem. Radius, 10 times 10 to the power of negative 6 meters. And then V minus mg. So now m is that. I'm going to plug that in. So I'm going to do 4,000 pi over 3. And then r cubed, I'm going to plug in the radius of this water droplet. Cubed and just no space equals 0. As you can see, I did forget to put the g right there at 4,000 pi divided by 3. It really should be 4,000 pi g divided by 3, then multiplied by r cubed. All the math later does check out. I just forgot to put that g there. Sorry about that. And now I'm going to plug it onto my calculator, and once you do that, you'll get 8.7 times 10 to the negative 11 v squared plus 3.1 times 10 to the negative 9 v minus 4.105 times 10 to the negative 11 equals 0. And so you can use the quadratic formula, or you can plug it into your graphing calculator and graph this. And once you graph it, find the 0, and we discover that the terminal velocity of this water droplet is 0.013 meters per second. And that is the answer to part A. And so to find the answer to the rest of these at 10 micrometers or 100 micrometers or 1 millimeter, you simply just change the radius, plug in the respective radiuses for parts B and C. And so once you do that, you will get R2 equals 1.028 meters per second. And when you plug in R3, you will get 6.693 meters per second. R2, by the way, was 100 times 10 to the negative 6 meters. R3, by the way, was 1 times 10 to the negative 3 meters. Plug these into R, graph it, and get, use just like how you would solve any other quadratic equation, and you will get these respective speeds for those radii. And that is how you do problem number 59.